This is your review for the Module 10 quiz in geometry. And what I suggest you do is, if you think you are pretty sure you've done everything and you think you know that you've done at least some of it correctly, you might want to go ahead and scroll forward to the end of the video, and I will just go ahead and make sure I show all the completed answers all together at the end of the video so that you can check and just go back to the part of the video you need to watch, because I'm just going to work all the way through. Looking at 1, 2, 3, 4, 5, 6. What you have here is, on all 6 of these problems, you are given all 3 side lengths of the right triangle, and you're being asked to find the value of the cosine, or the value of the sine, or the value of the tangent. Now on your quiz, when you're asked to do this, just like in your homework, you're asked to do it in a fraction and you're asked to do it in a decimal. We're going to round our decimals to the nearest hundredth. So for instance, number 1, cosine of x. That means I need to figure out which side is adjacent, which side is opposite, which side is hypotenuse. You always need to figure that out. And here we have adjacent is 12 and hypotenuse is 20. Cosine is adjacent over hypotenuse, so that's why I care about those 2 sides. Remember, sine is opposite over sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if I'm asked about the cosine, then I want the adjacent and the hypotenuse. And so I put 12 over 20, and I simplify that. When I simplify 12 over 20, I get 3 over 5, because 3 goes into 12 4 times, and 4 goes into 12 3 times, and 4 goes into 20 5 times. And that is also 0.6. Going from 3/5 to 0.6 just means going to your calculator and doing 3 divided by 5. So that's number 1. I have a rather poor pen here, so I'm going to see about switching to pencil. Second one, cosine of A. Cosine means I need the adjacent over the hypotenuse. So the cosine of A is 10 over 26, which I need to simplify, and when I simplify that I get 5/13 as a fraction, and change that to a decimal by doing 5 divided by 13, and that gives me approximately 0.38. That's my answer for number 2. Number 3, sine of x. Sine is opposite over hypotenuse. Please remember, by the way, when I'm doing a video, that you can pause at any time. So the sine here of angle x is opposite over hypotenuse is 15 over 39. Both of those are divisible by 3, so I'm going to simplify that to 5/13, and we just did 5/13 as a decimal. That's 0.38. Number 4, cosine of x. Cosine is adjacent over hypotenuse. So cosine of x here is 24 over 30. I can simplify that by dividing 6 out of both, and I get 4/5, which is 0.8. Again, the way I get the decimal is dividing 4 divided by 5. That's what a fraction means. Number 5, cosine of C. Cosine is adjacent over hypotenuse. So I'm going to need the adjacent and the hypotenuse. So cosine of C equals 18 over 30. 18 and 30 are both divisible by 6. That's 3 and 5, and that's also 0.6. Just like number 1. Finally, sine of x. Sine is opposite over hypotenuse. So sine of x here is going to be 5 over 13. We've already reduced that a couple of times, or changed that to a decimal a couple times, and gotten 0.38. All right, on number 7 and 8 and 9 and 10, you're finding a missing side length. When you're finding a missing side length, you're using sine, cosine, or tangent. Not inverses, just plain sine, plain cosine, plain tangent. Okay, just pressing the button on your calculator when you get there. You don't press the button until you have everything you need to have, which means you solve for x first. Before we even do that, we set up the equation. So the first step here is to set up the equation. We set up the equation by looking at our angle and which side we need and which side we have. The side we need here is x, that's the adjacent side. The side we have here is 20, that's the opposite side. So this tells me I'm going to use the tangent because I'm working with opposite and adjacent. And that all goes back to SOHCAHTOA. Opposite over adjacent is tangent. So I set up my equation. That's always the first step. Tan 71 equals opposite over adjacent. So that means I'm going to have to get the x out of the denominator. So I'm going to have to multiply both sides by x. This is the only time that you would multiply by x is when you're trying to get it out of the denominator. So I'm going to multiply by x on both sides. And what that gives me is x times tan 71 is 20, equal to 20, because these will cancel. X over x is just 1. So now I've got x times tan 71 equals 20. X still is not by itself. This is solving an equation, so it's all about getting the variable by itself. You do whatever you have to do to both sides to get it by itself. Once x is by itself, which it is now, x equals 20 over tan 71, that's when I go to the calculator and I put in 20 divided by tan 71, and I get 6.886. Says round to the nearest tenth, so I'm going to do that. So I get 6.9. So that's my missing side length. Number 8. Number 8, I'm working with this angle down here, the 59 degrees. The opposite angle is 20. The adjacent, that's not an angle. Opposite side is 20. The adjacent side is x. X is what I need to have. I'm not dealing with hypotenuse here. I'm just dealing with opposite and adjacent. So that's tangent. So tan 59 equals opposite over adjacent. We're solving this very much like we did the last one. This one has an x in the denominator and I have to get it out first. That's the only excuse for multiplying by x, is if you have to get the x out of the denominator. And so then I have x times tan 59 equals 20. Once x is out of the denominator, it's just getting everything else away from x. So I'm getting this away from x by dividing it out. And I have x equals 20 divided by tan 59, and that's what goes in my calculator. 20 divided by tan 59, and I get 12.017, which is going to round to just 12.0 for the nearest tenth. Okay, next, same thing. We're still finding missing sides on numbers 9 and 10. On number 9, this is the angle I'm working with. Remember, you don't ever work with the 90-degree angle, just the two acute angles in the triangle. So I'm working with that 73, and for the 73, the 11 is adjacent and x is opposite. We got an awful lot of tans here. Number 10 is not a tan, so that's nice. So this is tan because it's opposite and adjacent. Tan 73 equals x over 11. The other nice thing about this one is that I don't have to get an x out of the denominator. I can just focus on getting things away from x. So that means I'm going to multiply both sides by 11. Now x is alone, and I have 11 times tan 73, and that's what goes in my calculator. So I go, and you can't see that very well, but 11 times tan 73. And I get 35.979. We're going to the nearest tenth, so that would actually be 36.0. Okay, you don't have to do the little squiggly lines. They just mean is approximately equal to. Okay, I'm going to do them because I'm a math teacher, and so I'm going to do what I'm supposed to do mathematically, but I'm not going to count off if you put equals when it's supposed to be approximately equal to. All right, next one. Here's 38. This side is opposite from 38, and this side is the hypotenuse. Okay, so if I'm working with opposite and hypotenuse, I have to do sine, because sine, S, goes with O and H. Remember, SOHCAHTOA. Sine is the opposite over the hypotenuse. So that's what I'll use. So sine of 38 equals opposite over hypotenuse. To get x alone, all I'm going to have to do is multiply both sides by 13. So I get 13 times sine of 38, and this is when I go to my calculator, once x is already alone. And I get x is 8. It's approximately equal to, but it's pretty darn close. Okay, numbers 13 through 18 actually ask me to find an angle. It's only when I'm finding an angle that I'm going to use the inverse function. So this time, if I'm trying to find an angle, I'm not going to use sine, cosine, or tangent. I'll use inverse sine or inverse cosine or inverse tangent, because that's the only way to get those things away from the angle name. Like if I have sine of x and I'm trying to get the sine away from x, the only way to do that is to make it an inverse sine, which basically puts it on the other side of the equation. So let's look at that. We always set up the equation the same way to begin with, the same way we did up here. We figure out which sides we're working with. So this is the opposite, and this is the hypotenuse. And then we decide which trig function we would need to use based on those sides. Since I'm using opposite and hypotenuse, that's sine. So sine of, let's just call the angle x instead of question mark. Sine of x equals opposite over hypotenuse, so 19 over 32. If I want to get the sine away from the x, I move it over here as an inverse sine. Inverse sine of 19 over 32. So x equals inverse sine of 19 over 32. And that's what I do in my calculator. To do inverse sine, I'm going to hit the second button first, and then the sine button. That's what that little -1 symbol is. It's the inverse symbol. It does not mean do -1 power. It doesn't mean do anything with -1 or subtract 1 or anything. It's just a symbol that means this is the inverse of sine. I'm working backwards. And when I do that, I get 36.4. So x is about 36 degrees. This one says, and you always want to check when you're trying to figure out what do I round to, check the directions. This says to the nearest degree, so that's a whole number degree. So I rounded to the whole number. Number 14. Here's the angle I'm looking for. Let's call it x. This is the adjacent side. This is the hypotenuse. Adjacent and hypotenuse are cosine. So cosine of x equals adjacent over hypotenuse. To move the cosine away from the x, I put it on the other side as an inverse cosine. So inverse cosine of 9 over 10 equals x. And I get 25.8. 25.8 rounds up to 26, so that's 26 degrees. Okay, number 15. This one we have the adjacent and the hypotenuse, so we're going to use cosine again. So we're going to end up doing inverse cosine of 20 over 29. You could set up the equation the same way to begin with. Cosine of x equals 20 over 29, and x equals inverse cosine of 20 over 29. So in your calculator, that's going to be 46 degrees. Number 16. This is the opposite, this is the adjacent, so I'm going to use tan. Tan of my x equals opposite over adjacent, so x is going to be the inverse tan of 6 over 8. And you could simplify that if you wanted and put 3 over 4, but you don't have to. And I get x is 36.86 degrees, so that's 37 degrees. And I'm sorry I'm not putting my answers in the consistently same place. This one was 36, 26, 46, 37. Number 17. This is my adjacent. This is my hypotenuse. So I'll use cosine. Cosine of x equals adjacent over hypotenuse. That means inverse cosine of 14/17 is how I get x. So inverse cosine, 14 divided by 17, that's 34.56. It's about 35 degrees. And last but not least, here's adjacent and hypotenuse. That's cosine again. Cosine of x equals 11/13. X is inverse cosine of 11/13. Inverse cosine, 11/13. I get 32.2 degrees. That's about 32 degrees. Now numbers 18, 19, 20, and 21 are taking into account the fact that you're not always told just find this one thing. Okay? Sometimes you're told to solve the right triangle. Remember that solving a right triangle means finding all of the missing side lengths, all of the missing angle measures, everything that's missing. So like for instance in number 18, I have to find a missing side. That's side AC. I also have to find a missing angle here and a missing angle here. So I don't have either one of the two acute angles, and I don't have side AC. If you don't have any of the acute angles, that means you're going to have to use an inverse function to find it. Okay? We only use an inverse function if we are missing an acute angle and need to find it and have no other way of finding it. Okay? So if we have neither one of the acute angles, that's when we're going to use inverse function. Which tells me on number 19, I will not have to use an inverse function. On number 20, I will not have to use an inverse function. I'm only going to have to use an inverse function if I don't have an acute angle. So number 18, let's go ahead and start by finding one of those acute angles. Let's find angle B. It's really your choice as to which angle you want to find. I chose angle B for no particular reason. For angle B, this is the adjacent and this is the hypotenuse. You always, always, always start by identifying which sides we're working with. If I'm working with adjacent and hypotenuse, that means I'm going to use cosine. So cosine of B equals 25/30. This is just like 13 through 18. B equals inverse cosine of 25/30. So B is, and I should say approximately, now that I said I was going to do that, I start forgetting to. Approximately equal to 33.55 degrees. That's 33, rounds up to 34 degrees. So if B is 34 degrees, the way I can find the other acute angle is subtracting from 90. The two acute angles in a right triangle always add up to 90. That's because altogether, remember, all three angles add up to 180, and I've already got 90 here. So if I'm already using 90 degrees out of 180, that means I've only got 90 left for these two. So 90 minus 34 gives me 56, so angle C is 56. So I'm already almost done. Only thing I have left to find is missing side length AC. Since I know AB is 25 and I know BC is 30, I have two sides of my right triangle. Anytime you have two sides out of three on a right triangle, Pythagorean Theorem is probably the easiest way to find the third side. So let's call this one x. 25 squared plus x squared equals 30 squared. Remember that you don't just square and add the numbers you see, because this is the hypotenuse, so it has to be the one that's alone on one side. So I get 30 squared, which is 900, minus 25 squared, which is 625. And that tells me x squared is 275. When I take the square root of 275, I get 16.583. And we've been habitually rounding side lengths to the nearest hundredth, so I'm going to go ahead and call this one 16.58. So the length of AC is 16.58. Number 19. This one we were already given one of the acute angles, so we will not need to do any inverses on this. I can find the other angle by simply subtracting 63 from 90. That leaves me with 27 degrees. I do have to find some missing side lengths though. So I'm going to find side XW first. Let's call this B, just because I've already got an X. And say I'm going to use the angle 63, and again, there's lots of different ways to do this. You could use another angle since we have both of them. But I'm going to use the angle 63, the 12, to find B. So the 12 is opposite from 63, and B is adjacent to 63. So I'm going to use the tangent. So tan 63 equals opposite over adjacent. Now this is one of those cases where my variable is in the denominator. I have to get it out before I can continue solving. So I have B times tan 63 equals 12. Now I'm ready to go ahead and solve. That means getting everything away from B. Tan 63 divides out so that B is now alone, and that's when I go to my calculator and do 12 divided by tan 63 and get 6.11. So B is 6.11. Now the easy way to find YW, now that we have XW is 6.11, is Pythagorean Theorem, because I know that this side YX is 12 and this side XW is 6.11. So I could do 12 squared plus 6.11 squared. That gets me 181 and some change, and then take the square root of that number. You always end Pythagorean Theorem by taking the square root. So this is 13.47. That's the value of YW. Next, number 20. I can start this one by finding the other missing angle by subtracting from 90. No need to do any inverse. So 90 minus 41 gives me 49. Then I can find either one of these two missing side lengths. I think I will find this one right here. How about this? Because I want to use this angle 41, and this is my opposite, and this is my hypotenuse, and that way I can use sine. So sine of 41 equals opposite over hypotenuse. X is not in the denominator, so do not multiply by x. I can multiply both sides by 32. 32 times sine 41 gives me 20.993. So that's about 21. So x is 21. And then I can find this third missing side by doing Pythagorean Theorem. So whatever squared plus 21 squared equals 32 squared. That means I'm going to have to subtract. So 32 squared, and you can write it out if you need to. 32 squared minus 21 squared. And that gives me 583, which is 24.14 squared. So 24.145, so it's really 15. Number 21. Again, I am not given either of the acute angles on this one, so I will need to find an angle.